I'm going to be presenting on black holes in space. So, who here likes science? Wow. I need you guys in my science class. But okay, so I'm surprised that a lot of people in this classroom like science. Usually they don't. So today I'm going to be discussing what I consider, and I think you guys will consider, one of the most interesting things about science, which is black holes. So we start with a black hole's birth, and after watching and researching and watching documentaries on YouTube, I found that there are two components I want to break it up to. So, which is the birth of a black hole and the effects it has on its surrounding, which is specifically Earth. So, the birth of a black hole comes from a supernova, and that's the first thing I'm going to be talking about. And the second thing I'm going to be talking about is going to be the effects it has on its surroundings, specifically Earth. So, the black hole is born with a supernova. What is a supernova? Well, a supernova is when a giant star, the sun is a star, when a giant star reaches the end of its life cycle, and it usually has two components that make it up, which is gravity. Everything has gravity, right? So gravity is the force that is pushing you towards the core of a mass, which is the sun. So you have a star, right? And you have the core at its center. So there's huge gravity pushing towards the center of the core. And you also have something called fusion. Fusion is what, when you see stars and they're bright and you see there's fire coming out, that's fusion. So the gravity and fusion, they balance each other out. They cancel each other out and you have a star. However, when a star reaches the end of its life cycle, it ceases to release fusion, and therefore gravity wins. So everything is condensed and everything is getting squished. And when everything gets squished, it explodes. Because it gets squished so much that it has to release that energy, and it explodes, and you get that supernova. In 2005, physicist Matt Tweed reports that put too much matter in one place, and immense attraction eventually forces atoms to totally degenerate, crunching neighboring nuclei together and collapsing electron shells completely. That is a lot of terms. But in other words, I just wanted to say it like this. So everyone knows what an atom is, right? Alright, so you have an atom and you have some of the main components that make it up: electrons, protons, nucleus, and other stuff, right? So imagine gathering a bunch of electrons. Imagine we're like atoms, and we're just going in together and just squishing as hard as we can, right? Well, eventually we're not going to be able to withstand, so something's going to happen, right? And what happens is it can't withstand the weight and pressure of too much collision, that we're going to explode. So that's supernova, and that's an interesting fact about that. So that is how a black hole is born. All right. So some of the main components that make up a black hole: the event horizon and singularity. Well, you see what you have in the middle right there, the ship. That's the singularity. Pretend this is a black hole. So you have a black hole, and in the center is a singularity. What is a singularity? All right, a singularity is the smallest point in a black hole where all of its density is at. So imagine the center of your body, and imagine that center of your body has your entire mass, your entire weight. That's dense, right? That's going to be heavy. So that's the same with the black hole. That's singularity is where everything gets pulled towards. So now we have the event horizon, which you can see right here, the circle, right? And you see the boat, it's right at the point of the event horizon. Well, what happens in the event horizon is that you have a bunch of matter, or a bunch of stuff, right? And you have a bunch of stuff, and once it gets to this boundary called the event horizon, it can escape the pull from a black hole because its gravity is too much to escape. So you're kind of stuck there, and you're going to get swallowed in like that ship. So, but however, if you're a distance away from the event horizon like this one, that boat, then you're able to escape the pull, just like a vacuum. So has anybody here killed a spider or sucked it in with a vacuum in the room? Yeah, right? So imagine, so you know that you have to get a certain distance close to the spider to suck it in, right? But if you know if that spider is too far away, your vacuum's not going to help you. So that's what that is. And then these are pictures of black holes. This looks blurry because everything is going towards it. It's so much gravity, it's pulling it into the center of that black hole. And I got that from the movie Interstellar, so that was pretty cool. And then we have the Milky Way galaxy. So secondly, I want to talk about, all right, so how does this impact us? Well, does it or does it not? That's the question. The thing is, you have a Milky Way, we live in a galaxy called the Milky Way galaxy, right? And at the center of the Milky Way galaxy and any other galaxy, you have a black hole. So, you see the distance right here says sun? Well, that's kind of where we are. And so you can see that we're like really far away from the center. So really there isn't much to worry about. The black hole can't suck everything in. It has, like I said, with a vacuum, it has to be a certain distance, right? So we're safe from that. And you see, scientist Smith from NASA noted in 2008 that even if a black hole, the same mass as the sun, were to be as a black hole, it wouldn't suck anything in. It would just, be there. So, the beginning of the universe. That's another way it impacts us. So we have this, and so we have a black hole, and it's pulling everything in, right? So where does that everything go? Well, it goes to the singularity. But what happens after that? Nobody knows really, but there are some speculations that that matter ends up creating another universe. So we might be a result of that. So lastly, I'm glad to present to you guys about these two components. Which first I talked about the birth of a black hole, and secondly how it affects us. So I hope that you guys like this, and I hope you guys find it more interesting. And thank you.